Automation is key to modern networking, and the foundation of network automation is REST APIs. So what are these REST APIs and how can we use them? Hi, my name is Rich and welcome to the Rich Tech Guy channel. And if you've been in networking for a while, you know that the command line interface is your go-to resource for configuring the network. But modern networks are really driving for a greater need of automation. And the tool that lies at the foundation of that automation is REST APIs. Now in my last video, I gave a little tutorial on how to use Python to automate Nexus 9000 series switches. And in that video, I used REST APIs to send command line commands to the Nexus switch. And now let's take a deeper dive and understand how we can build these APIs and utilize them for network automation. But first, if you like this content, go ahead and hit that like button. And if you haven't subscribed to this channel, what are you waiting for? Go ahead and hit that subscribe button too. All right, let's get into REST APIs. So what is REST? Well, REST stands for Representational State Transfer. And it utilizes HTTP, or the Hypertext Transfer Protocol, in order to send requests out. Now the HTTP protocol, or HTTPS, the secure version that we should all be using these days, utilizes what's called a request response system. You send a request out, response comes back. Okay, so this creates what's known as a stateless client-server model. You're the client, you send your request to the server responds, and once that's done, in terms of HTTP and that protocol, the transaction is complete. Everything is done. So we want to send that request out. Well, how are we going to do that? Though HTTP utilizes 5 different verbs, or essentially actions, that we are going to attach to our request. And those are post, get, put, patch, and delete. All right, so each one of those verbs utilizes a particular action. Post is going to utilize a write action. Get is going to utilize a read action. Put and patch are both going to utilize update actions. And then the easiest one to remember is delete, which will have a delete action. So we're going to take this request and we're going to send this to a URI, or a Uniform Resource Identifier. So what is a URI? Well, that's really just a fancy way of saying a web address. You know, just like if you've got your web browser, you open up a web page, up on the address bar at the top, there's going to be a web address there. Okay, so let's take an example URI and we'll break that down and go over everything that's going on with it, because it's a little bit more than just a simple web address. So here's our example URI. And the first thing that we're going to have with it is we have HTTPS. So that's our protocol that we're using. The next thing we have is we're going to have the address that we are targeting for this request. And so that's going to be the server or the device that we are targeting. And this can be either a qualified domain name that's registered on a DNS, or it can be an IP address. After that, we're going to have the path that we are trying to access. This will be a directory or file or files on that particular server or device. And once we get past that point, then we are going to have our query, which is flagged by a question mark, and then certain commands that might be sent within that query to the device. All right, so if this were a valid URI, when we send this request, we would get some responses back. And well, we would get a particular response back, and depending on how that URI was sent and the payload, which we'll get into later, what was in that, we're going to get a particular type of response back. So here's a table of various responses, and the way to summarize these really is if the code on the response is in the 200 range, that means everything was great. It's awesome. Go ahead and hit that like button, and if you haven't hit the subscribe button already, hit that too. And the next one that we need to be aware of is going to be the 400 range. Now, if it's a 400 range, that means there's something wrong with your request. So unless we've gotten an unauthorized or forbidden code, then if we get one of those, we need to check our credentials and make sure everything is good there. Otherwise, we just need to check the request we're sending. Maybe something was wrong in the formatting of the request, but it's something that needs to be worked out. And then you have the 500 level codes. If you have a 500 level code, that means that something is wrong with the server side of the request. And so, it's the server basically telling you, it's not you, it's me. If you have admin access to the server or the device, you need to log in there and figure out what's going on. If you don't, then you need to submit a trouble ticket with whomever does have that access. All right, so we've sent over our REST API request, and we got a response back. That's great. But when we're sending this over, we need to have a payload containing a set of instructions for the device to operate on. And when we send that payload, there are really two major data formats we can use for REST API. We can use XML or we can use JSON. Now, XML stands for Extensible Markup Language, and it utilizes a bunch of tags similar to the way HTML does. This creates a rather bulky format, and in many ways XML is really starting to fade away in terms of its usage because of that. Now, there are still instances where you might need to use XML. For instance, if you're working with Cisco UCS in UCS managed mode, then the configuration is going to be XML based. But as we move forward and as time goes on, we're finding that more and more the preferred method of formatting the data is going to be with JSON. So what is JSON? Well, JSON stands for JavaScript Object Notation. And don't let that name fool you. The reason it got that name is because it is based off of a subset of JavaScript. But it doesn't actually require JavaScript, and you don't have to know JavaScript in order to utilize JSON. Because JSON is just it's a language-independent data format, and it is supported by just about all of the major computer languages out there. In fact, Python utilizes JSON really well, as Python can easily parse that data out into dictionaries and lists. So up on the screen, I'm going to point out or put up the data for both XML and JSON. This is the exact same data formatted in the two different styles. Now, the thing I like about JSON is the key names appear only once, and then the data associated with those keys are going to be placed directly after a colon. Whereas with XML, you'll notice that there's a tag at the beginning and the end, sort of an opening and a closing tag, and it spans the associated data. All right, so let's create some REST APIs and use them to interact with a Nexus switch. And in order to do this, I'm going to be utilizing a tool called Postman. Now, Postman is available for Windows, Mac, and Linux, and I'm going to post a link down below on where you can get it. But it's a great tool to play around with, as essentially it's a REST client tool that allows you to create, build, essentially the same thing, send, test, debug, all sorts of stuff with APIs, with the REST APIs. So let's go ahead and get into playing around with this. All right, so to start off with, I am in the NX API sandbox, which I featured in my last video where I was using the APIs to interface with a Nexus 9000 series switch. And in that video, I was using this method NX-API CLI. However, as we're going to dive deeper into the REST APIs for this, I'm actually going to switch that method over to NX-API REST, the DME. The input type we will leave as CLI. Now what I plan to do here is I'm going to configure OSPF on a switch and get it to talk to other OSPF and receive routes. Okay, so to start with, let's configure a loopback address that we're going to use for the switch router ID. So let's input the commands of interface loopback 0 and give it an IP address of 10.10. There we go, 42.2. All right. So instead of hitting send on this one, what I'm actually going to do is I'm going to hit convert. Okay. First thing it's doing is it's telling me I have a invalid. Okay, yep. I needed to add the CIDR notation, so there we go. All right, let's hit convert again. All right, everything's good. And now what we have here is we have this request that we can send over to the switch. However, what I'm actually going to do at this point is in order to better interface with the switch utilizing these APIs, we need to get a token off that switch. So if I were to go over to the Python 3 tab here and I scroll down, by the way, there's our payload here, the same one that was in the request. But if I keep going, I'm going to have this function here, AAA login. And in it, it's going to have this payload here that we can use to get a token for the switch that we can then utilize for future interactions with that instead of having to continuously send the username and password over. So what I'm going to actually do is I'm going to pop into Sandbox here, and I actually already have this sort of preset. So one of the things that we're going to have to look at here is because this is actually set up in Python format of a dictionary with dictionaries inside of it. Essentially we've got some nested dictionaries. But Python is using single quotes. The other thing that Python is doing is not placing quotes after the or around the vowel, the variables, the actual information. And that's something that if we're going to switch that into JSON format, we need to do that. Okay, and the other thing that we need to note is we've got the URL. It says HTTP. We're going to need to add an S, HTTPS, the IP address, and then this is the path of the URI that we need to access afterwards. All right, so we're going to go back. I've already subbed out the username and password with what I need to interface with the switch. I've put in the double quotes here. Another thing that we need to do on this, if we're utilizing self-signed certificates for the HTTPS, is we have to go into settings here, and under enable SSL certificate verification, that needs to be off. Notice it says restore default because the default value would be on. So we need to make sure that's turned off. And then we go back to the body here. All right, so now what I'm going to do is I'm going to hit send, and there we go. It has now come back with an HTTP status of 200. All right, everything is good there. And what I'm going to do here is it's got it right now in a pretty format here. I'm actually going to switch over to raw, and then I'm going to grab the token out of that. All right, so let's go ahead and copy that. And now I've got my actual request that I'm going to do. So the request, this JSON formatted information here, and by the way, under the request tab, this actually is properly formatted for JSON. And this is the path we're going to utilize, this API/mo/sys/JSON. So I've got this second request here. Now what I need to do is I need to take that token I grabbed under this authorization tab, and set that to API key. The key is APIC cookie, which I also got from the definition or the function within Python, or if I scroll down just a little bit further here, auth cookie, and it has a dictionary where the key is APIC cookie and the value is the variable token that it would have received from the switch. All right, so back over here, let's go ahead and paste that token that I got, and now I can utilize that to interface with the switch. Okay, so what I'm going to do now is I'm going to go and I'm going to copy the body here of this request, and back in here we're going to select, I've got a previous request here, so I am going to clear that out and replace it with my new body here. So I've got it set here under raw, and the format is JSON. Again, in settings, we verify that it is off. Okay, so as I said, this is to configure this loopback interface. So before we actually do that, let's verify on the switch whether or not we have the loopback interface. So I'm going to do a show IP interface brief, and I just have a ETH120 interface with an IP address configured on it. And then let's also do a show run intlo0. It says invalid range. This interface doesn't exist. So let's go back over to Postman and let's go ahead and hit send. And I have a status 200 OK with IM data. Okay, so now if I go back into the onto the switch login here, and if I repeat that last command, yeah, there's a interface loopback 0. All right, so if I do a show IP interface brief, there's loopback 0, and it's got the IP address and it's up. So we have now got the loopback interface up. So let's create another series of commands. As I said, we want OSPF to be configured on this switch. So what I'm going to do now is I've already got the feature OSPF active on the switch. So I'm going to put in router OSPF and give it a name. All right, and then we're going to set the router ID to the loopback interface address. So router ID is going to be the IP address there. And then what I'm going to do is I'm going to actually go and we're going to go back onto the loopback interface. Okay, and then we are going to activate that interface on the OSPF neighbors and for advertising the route. So let's put in IP router OSPF, give it the name and the area. Okay, and then if we go back over to that switch, I have this other interface, Ethernet 120 with an IP address configured. So let's configure that one too. And IP router OSPF. Okay, so again, let's click convert. And we've got all of our information here. Okay, it's got the information of the OSPF instance, the name is underlay. We have the router ID here. Okay, we're going to go over to some children, the interfaces, Ethernet 120, advertising area 0, loopback 0, also on area 0. All right, and then we've got some secondary data also being passed over. Right? So let's click copy. And we're going to go back in here and let's select everything here. clear that out from the previous request. And let's go ahead and paste that new payload. Okay, so before I send that, let's go back over here and let's do a show run OSPF. As I said, the only thing there is feature OSPF. There's no other OSPF configuration. In fact, if I say show IP OSPF neighbors, nothing. It says there is no OSPF process running. Alright, so let's go back into Postman and we're going to hit send. We've got the status 200 OK and I am data. Alright, so let's go back in here and we are going to do the let's do that show run OSPF again. Alright, so there's our router or instance of OSPF created. The router ID is established. We are now advertising OSPF on on these particular interfaces. And if I do a show OSPF neighbors, oops, that's show IP OSPF neighbors, it's picked up a neighbor. And now if I do a show IP route, look at that, I now have some OSPF routes populating in. Alright, so there we have it. We have now just created the, or utilized REST APIs to automate our process with the switch. And now we can take that and plug that into our programming language of choice. Alright, so now that we have a basic understanding of REST APIs, we can use that as a foundation and take that and just put that into our preferred coding language and use the code to send out that REST API payload to the device, receive a response back, verify that everything went great in the configuration and that the networking device is operating as we expect it to. So there's a lot of great resources around REST APIs and then how to use that for network automation. Cisco has some great information out there on their DevNet website. I will post the link down below. So please feel free to use that. I absolutely encourage going through there and going through some of their learning paths. The other thing that I will post down there will be some additional learning resources. Those will be affiliate links, so do with that what you will. And once again, if you made it this far, please go ahead and hit that like button. And if you're not subscribed to this channel, please subscribe for more great content like this. And as always, keep learning, keep improving, keep studying. I will see you in the next video.